I do apologize, but I'll have to do the talk in Hebrew. No, just kidding. My name is Adam Carmi. I'm the co-founder and VP R&D of ApplyTools. We're a company that provides a cloud service for automated visual testing. I'm very happy to be here with you and talk about visual testing, so thank you for having me over. As part of my job, I get to meet a lot of developers and testers, and I'm always curious to learn how they do visual testing. And most two common answers that I get is that one, they don't know what visual testing is, and two, they think I'm asking them whether or not they're using Sikuli for testing. So the main thing I hope you'll take away from today's session is that you understand what visual testing is and that you can and should automate your visual tests. But if in addition you also remember that visual testing that does not equal Sikuli and tell that to everyone you know, that would be a huge bonus for me. So we have a lot to cover today. We'll start by explaining what visual testing is and why it should be automated. Then we'll take a deep dive and review some of the tools, the Selenium-based tools, and the technology that they use under the hood. And the last part would be we'll discuss how automated visual testing can fit or plug into your development processes. We'll, of course, have time at the end to answer any questions that you have. So what is visual testing? It's a quality assurance activity that is aimed to verify that the graphical user interface appears correctly to the end user. Now, this goes beyond the traditional functional testing that you used to do with tools like Selenium and Appium and others, where you verify the functionality of the application through its UI. What we are focusing on here is making sure that the UI itself appears correctly to the end user. We want to make sure that each UI element appears in the right color, shape, position, and size, that it doesn't overlap or hide any other UI element. This type of testing has become increasingly difficult to perform in recent years, mainly because of the explosion in the amount of devices, browsers, screen resolutions, and operating systems that applications are expected to run on. So here you can see an example of a visual bug we found in a Microsoft Azure management platform. You can see how the graph exceeded the expected bounds of the page. This one is from Twitter. You can see that the timestamp of the notification overflowed on top of the notification that's below it. This one is from the Financial Times, and you can see how the title of the article overflowed on top of the article body. And this is how the Amazon website looked like for several hours for certain users on Amazon Prime Day, which was like a huge sales day. And so I'm sure that it's not the first time that you see this kind of bugs. I'm sure that you see them like at home when you're using the web or your mobile devices. I hope you don't see them too much at work. But you do understand their severity. They can be embarrassing. They can hurt the company brand. But in many situations, they can also completely cripple the functionality of a web application or a website and end up costing a lot of money, just like what probably happened here. So why should we automate this type of testing? After all, we've been doing it manually ever since, right? So there are many reasons, but the most important one is that the test matrix is just too big to cover manually. So think of all the different web browsers, devices, operating systems, and screen resolutions that your application is expected to run on. We all know that if a website looks good on Chrome, doesn't mean that it would look good on IE, right? And if an app looks good on a widescreen, it doesn't mean that it would look good on a smartphone. So we have to test on all these different environments, and that takes a lot of time and effort. If your application is responsive, and most modern applications are, then you also need to factor in the different layout modes and test them against all these different execution environments. If it's localized to other languages and locales, then there are different resources and images and fonts and content that is specific to each locale and affects the UI. And of course, even if you don't change a line of code in your application or website, you still depend on third-party upgrades that could actually mess up your site. So Chrome and other browsers, they update every 2 weeks. Whenever they do, they can introduce incompatibilities with your application, and that can end up resulting with bugs. When it comes to mobile applications, quality is even more critical. The main reason is that it's much harder to roll back changes. So if you have a bug in production, you're stuck with it for some time. It's not like the web when you can easily just fix it and everyone will see the fix. You cannot push daily to the App Store, and even if you find ways to work around that, frequent updates take battery and data and end up upsetting your users. And in general, there's a much higher quality bar when it comes to mobile applications, simply because mobile users are much less tolerant to UI and UX bugs. And of course, as we all know, release cycles keep getting shorter and shorter, which doesn't leave much time for testing. Companies that are practicing continuous deployment today release code to production several times a day. And with such short release cycles, there is hardly any time to do any type of manual testing, let alone making sure that your app looks right on so many execution environments. Okay, so now that we understand what visual testing is, let's take a look at the tools and understand how they work. So all the visual test automation tools that are out there, and there are many of them, there are over 30 of them, all share the same simple workflow. It has 4 steps. In the first step, you drive the application on this test and get screenshot. So we're in a Selenium-related conference, and there are many, you can use WebDriver to do that part of the workflow. In the second step, the tool takes those screenshots and compares them with baseline images. These baseline images dictate the expected appearance of the application. In the majority of cases, these are screenshots that were taken by the tool in the past and were approved by a human tester. Okay? In the third step, the tool takes those screenshots and baseline images and the comparison results and builds a report. And in the fourth step, a user, a tester, a human tester, has to look at that report and decide for each change, if there were any, decide whether this change is a bug, in which case he opens a bug, or if it's a valid change to the application or website, he approves the new screenshot, so that will become the baseline for subsequent runs. Okay? Of course, there's the first time you run a test, it still doesn't have a baseline. And so in this case, the first run usually creates the baseline images, and from the second run onwards, you always have something to compare against. So now that we understand how these tools work, let's take a look at our first demo. And in this demo, I'll show you WebDriver CSS, which is an open source visual test automation tool that works with WebDriver IO. Okay, so for those of you who are not familiar with WebDriver IO, this is a very simple test with WebDriver IO. It's a JavaScript WebDriver. And this should look very familiar to you. What we do here, and right now it has nothing to do with visual testing, is that we create an instance of the driver, and we instruct it to start with the local Chrome browser. Then at the beginning of the test, we initialize the driver, which basically opens up the browser. Then we navigate to WordPress.com, and then we just wait for 10 seconds. So it's a very, very simple test that really does nothing. What we'll do next is that we will add in WebDriver CSS, and this will allow us to perform a visual validation checkpoint. And it only takes a few lines of code. What we do is that we create an instance of WebDriver CSS, and you provide it with a WebDriver IO instance. And what it will do, it will actually inject the visual validation capabilities into that driver. And we also indicate the screen width that we are interested to test our application on. Now, this is important, especially for responsive applications, because what happens here is that before each screenshot is taken, the browser is actually resized to those widths, and it forces the application to assume the layout mode that we want to test it under. Okay? If we look at the test itself, then right after we navigate to WordPress.com, we perform the validation point. It's called, with WebDriver CSS, it's called WebDriver CSS, and we provide it with the name of the checkpoint. In this case, it's WordPress, and then a list of elements within the current page of the application that we want to validate. So in this case, it's just one element. It's the body element. You can use any CSS selector here to indicate it, and you provide it with some nice, meaningful name. In this case, it's homepage. So let's run this test and see what happens. Okay, so you can see the first resize and the second resize. You can see that the application is responsive. It's actually changed the layout mode, and we're done. And if we look at the folder where we just ran the test, you can see that we have two images created for us, two baseline images for each element. So in this case, it's the homepage checkpoint it's the WordPress checkpoint for the homepage element. And we have two of them, one for each screen width, okay? If we open one up, you can see that we actually have a simulated full page screenshot. As you probably know, if you ask Chrome for a screenshot, it would only give you a screenshot of the viewport, whatever is visible above the fold. So what WebDriver CSS did is that it took many screenshots and it scrolled the website and it produced a simulated full page screenshot for you, which is great because you get more coverage. The next thing I'm going to do is that I'm going to inject a small change into the website and rerun the test so we can see how WebDriver CSS picks it up, okay? So the only thing I'm doing here is just after navigating to WordPress.com, I am finding the create website button and I'm making it hidden. Okay, so let's run the test and see what happens. Okay, so you can see here the missing button as expected. And we're done. So if we look at our folder right now, you can see that we have two new images that instead of a baseline suffix have a regression suffix. The reason we have those is because the tool found that the new screenshot did not match the baseline images. If we open these images, you can see that it does show us the new image with the missing button in this case. In addition, there's also a diff folder that shows us the same new image, but with all the different pixels highlighted in pink. So it makes it easy for us to identify which pixels have changed between the images. And so what I want you to take away from this demo is to realize how easy it is to take your existing Selenium test and just with a few lines of code, turn them into visual test automation tools that allow you to check more, okay? So let's move on and drill down into the specific steps. And I'll start with the second step of comparing screenshot with baseline images because I'm sure that many of you now thinking in their heads, this image comparison is probably so fragile and the tests are flaky. So let's tackle this one first and to give you better understanding of what's happening. Okay, if you allow me to quote Boromir, so one does not simply do bitmap comparison. And the reason is that if you simply go pixel by pixel and compare the images, you'll get a lot of false positive and you end up hating the tool and throw it away. And we don't want that to happen. And the reason, and false positives in the case of visual testing is situations where the tool tell you that there's a difference, but it is so minute that you cannot see it as a human or you don't care about it because it's too small. And there are many reasons for these false positives to occur if you're doing just stupid pixel-to-pixel comparison. So let's look at a few of these. So the first one is related to an image processing effect that is called anti-aliasing. I'm sure you've heard about it. And here is an example of it. So we have a navigation bar here at the bottom. And you can see the playlist tab, which is blue with white text on it. And here is the playlist text being magnified. So you can see that although the text here is white, and probably in the DOM, if you look at the DOM for this element, you'll see that the color is white. Still, you can see that the pixels are not all white. There are a lot of shades of blue there. And these are actually anti-aliasing pixels that are placed there by the rendering engine. It could be the graphics card or whatever is painting the pixels. And the reason these shades appear here is because the rendering engine is trying to make the font seem smoother and more beautiful to us as humans, which is a great thing. The problem with anti-aliasing when it comes to visual testing, that whenever you are running your tests on more than one machine, which makes sense if you have more than one tester in your team or if you're running your test in a lab, then it's very likely that you'll have different graphics card there, or maybe a different configuration or different version of the device driver, or maybe the machine is connected to a different screen, which also affects how the pixels are generated. And then what you get is a different implementation of the anti-aliasing algorithm. And for instance, if we look at the same exact application rendered on a different machine, you can see how different the anti-aliasing pixels can be. Then again, on the original image, you cannot see any difference, but if you look up close, you can see that the pixels are different and even in a different color, okay? So in order to succeed with visual testing, you need to have an image comparison engine that is smart enough to be able to detect that these are sort of changes that a human being cannot see and should not care about, and so it should not treat these pixels as different in failure tests. Here's another very common example that has to do with pixel brightness. So you can see the text here at the bottom, and the word D is magnified. And you can see how different the color, the intensity of the pixels can be, even if you connect the same machine, the same host machine to a different screen. Okay, and then again, you need a tool that will be able to detect that this is just a brightness issue that really nobody cares about, and you don't want your test to fail over these causes. The next example is from the Dropbox website. I'm sure that you're all familiar with it. And what happens here is that the upgrade account element is moving. The reason that it's moving is because to the right of it, there is a username. And whenever we run the test with a different username of different length, then everything is moving with it because it's bound to it. Now, we would still like to visually test this. And so one thing that we can think of resolving this is just take a screenshot of only this element and compare it with the baseline of only this element. And so it doesn't matter where it appears on the page, we can still compare it. This is a very good idea, but the problem is that if we're doing a basic pixel-to-pixel comparison, it would still not work. And the reason is that although it seems like this element is moving as a whole, actually each individual letter is positioned independently to the others. So if we would overlay the upgrade account element one on top of the other, you can see how the different letters, A, C, and O, are actually positioned at different locations. And so this is not a minor difference, okay? So there are many pixels here that are different, and you need your image comparison engine to be smart enough to detect that and ignore these issues. The last example is also very common and has to do with image scaling. So whenever you have an image element in your web page or your mobile application, and the image that is being shown in that element doesn't have exactly the same size as the element that is being placed on the page, then the rendering engine have to scale that image so it would fit those bounds. And then again, two different machines will produce different scaling algorithm implementations that would result with different pixels. So if we look at this rectangle here at the top, you can see how differently these pixels can be drawn by different graphics card, but still all of this is completely invisible to a human. And there are more issues. So there could be arbitrary 1 pixel offsets in positioning of text, but even if you look at an HTML table, you can have a column that gets to be 1 pixel wider for no apparent reason, and when that happens, the entire page moves 1 pixel to the side and can produce 70% pixel-wise difference on the page, but still it's completely invisible to a human, right? And we don't want the test to fail over that. You need to deal with dynamic content such as dates and usernames and ads and all of that. There are moving elements like animation and maybe like the upgrade account that we saw that is moving. You need to be able to compare images of different size, and also the algorithm has to be very, very fast so our test won't take forever to run. And of course, there are those that no matter what they do, they always get mismatches. But seriously, if you want to go into visual testing and you're trying to choose your tool, make sure that the tool does not produce these false positives for your application, because if you continue to get them, you'll never be able to successfully scale up your test. It will just mean more overhead for maintenance. So let's take a look at the different image comparison engines that are available, and all these different tools are all based on them. It's not that each tool builds its own image comparison mechanism. So the first one is ImageMagick, and it's a very powerful command line tool for general purpose image processing. It's an old tool, and it also has one command that allows you to compare two images. And this is how it looks like. You call compare, you pass it in a first image and a second image, and it has two outputs. The first is that it outputs the number of pixels that are different between the two images. The second is a diff image, which is exactly the diff image that we've seen. It's the second image with all the different pixels painted in pink. The tools that are based on image magic usually expose some kind of error threshold that you can use to determine if images match or not. So what tools do is that they take this number, the number of different pixels, divided by the size of the image, and then you get an error ratio. And in your test, you can specify, for instance, that if the error ratio is above 0.5%, the images are considered to be mismatching, and if it's below that, they are considered to be matching, okay? ImageMagick also have a fuzzing feature. It is being configured here that allows it to overcome some of the false positives that we've seen in previous examples. Next, we have the three common popular JavaScript engines. The most popular of them is Resemble.js. This is the engine that is used by Phantom CSS. If you know, it's a very popular visual test automation tool. And it also does pixel by pixel comparison, and it's based on error ratio, but it has very good treatment of anti-aliasing pixels. Another thing that's cool about Resemble.js is that it has a very nice web page where you can actually, let's take images from the previous demo. You can drag one image and the other. Where's the regression for it? Here. Just a minute. And then you see the results for the comparison here, and you can play with the parameters. So it's very nice to just to test and see how it works for your application if you just get screenshot and try it out. The other image comparison engines are quite similar to it. Some of them have all kinds of small capabilities, extra capabilities like handling color differences better and ignoring the blinking caret if you have like forms with a focus on it and a blinking caret on top of it. And we also have Applitools Eyes, which is a commercial image comparison engine that was built from scratch to handle all these issues. So it has very good treatment of all the different things that we've just covered. There are two special things about it. The first one is that it does not require any thresholds. So the tool could, on one hand, if the change is visible to a human being, it would flag it. If it's not visible, it would completely ignore it. And it has nothing to do with the size of the change, or the size of the images, or any error ratio. It's just a matter if a human can see it or not. And so you don't need to do any type of configuration. It just works. The second thing is that it supports visual layout matching. And instead of describing in Word what that is, I'll just show you a quick example. So the first use for layout matching is the ability to perform cross-device and cross-browser visual testing. So you use a baseline image from one environment to validate the structure or layout of another environment. So in this case, you have a baseline image that was taken on Chrome and the current image that was taken on IE. And if we toggle between those images, you can see how different the browsers render the text. Although the text is moving and some fonts change in size and text wraps differently in paragraphs, still, structurally, these images are consistent, and you can use layout matching to verify that that's the case. We have this radar button here on the right, that if we click it, it highlights differences that were found, and you can see that we did find a difference here at the bottom right corner of the page. And if we zoom into it, you can see that we did pick up a missing element in IE. So it's a very powerful way of, once you know that a certain environment is stable, you can use it to automatically validate structurally all the other environments and reduce the amount of baseline images that you need to keep and maintain. Another example that has to do with mobile, this case with Twitter, which is a very dynamic application. So here you have the baseline image taken from Samsung S4 and the current image from Samsung S5, and we have a few violations here. So first of all, the baseline image dictates that the first tweet should be aligned to the right of the image, and this is being violated here in the current image. Also, the last tweet should have an image with it next to it, and it's missing over here. So all these differences are correctly flagged and highlighted by the tool. On the other hand, if we toggle between those two images, you can see that the two tweets in the middle, although they have different images and different text in them, still they are structurally equivalent, and therefore the tool does not highlight them as different. And this leads us to the second use of layout matching, which is validating extremely dynamic applications or validating applications in production. So in this case, we have the Yahoo website, and you can see the baseline image and the current image that were taken at a 24-hour difference. So in this case, you can see that although the images are quite different and the articles are different, still structurally the pages are consistent, and therefore this test is passed. So I hope this gives you a clearer picture of what image comparison can be like. And actually, the tools have come a very, very long way in making this type of tests very robust. And I know of teams that are running tens of thousands of visual tests on a daily basis. So this is as stable and as powerful as it can get. Okay, so with this behind us, let's go back to the first step and take a look at how the different tools drive the application under test and take screenshots. So although all the tools share the same workflow, we can roughly divide them into two categories. The first category is the quick feedback tools, as we call them. And the common setup for these tools is that they use to render screenshots on headless browsers, most commonly Phantom.js and Slimer.js. And they are driven by a configuration file that usually has like a list of URLs that it visits and validates. The motivation for using these tools is to get fast feedback on code changes. So the typical user for these type of tools would be a front-end developer that is now making a change to a CSS file or to a component, and he wants to know quickly that he didn't mess up other parts of the web page, as usually happens. So he wants to set up something small and simple and local, and it should run in the background so it won't interfere with his work. And he doesn't really care too much about writing elaborate tests, so a configuration file with just URL will be fine for him and not too much maintenance to worry about. The disadvantage of these type of tools are partial coverage. If you're using Phantom.js and Slimer.js, this means that you're using WebKit and Gecko as layout engines, which are the ones that are used by Safari and Firefox. And you still have Chrome and IE, which are rather important web browsers that you're not covered with. The second reason for poor coverage is the fact that although the browsers update very frequently, these headless browsers update seldom. So you could have like versions that are a few months old. Your test could pass with Slimer.js, but you still have bugs in Firefox that the tool didn't pick up because you're using an old version of the layout engine. The second reason for the low coverage is the fact that you have very limited navigation in your application. It's limited to URLs. You cannot really do sophisticated interactions with the application, fill out forms, hover, move stuff around, etc. The second category of tools, which are the visual coverage tools, are used when you really want to make sure that your application does look right on all the different real web browsers and real execution environments on real operating systems. And you want to test as many UI states as possible. So you want a test tool that will allow you to do sophisticated emulation of user actions. And you want to execute tests in parallel because you have many tests and you want them to end fast. And so the common setup here is to use a WebDriver and Selenium Grid. Okay, so and the code and the tests themselves would be WebDriver based, so you can do practically everything a user can do. So the disadvantages of these tools is that they do require you to set up non-trivial test infrastructure, and of course you have to spend time writing those tests and maintaining them, but if you are test professionals, then anyway you have that in place, so it's not really a problem for you. Here we can see a list of the Selenium-based tools that are out there, and we won't go over them one by one, but what you can see is that for each language binding, there is a visual test automation tool that can be used to augment it with visual coverage capabilities. Also, you can see that the majority of them are actually code or script-based, and very few of them rely on configuration files because these are commonly the visual regression tools. And also, it's important to highlight that all these tools only work with the web applications or mobile web applications, except for ApplyTools Eyes that can automate native applications with Appium. So here's a sample of some non-Selenium-based tools. There are many of them as well, but you can see that the majority of them are configuration-based. They usually go to the quick feedback tool category, and that's about it. When it comes to taking screenshots, it seems like a trivial thing. After all, we do have like the WebDriver get screenshot method, so what's the big deal about it? But there is a lot of nuances there, and the tools differ in the way that they can handle it. So some tools will provide you with a simulated full-page screenshot, like we saw with WebDriver CSS. Some tools will just give you whatever the browser provided. Some tools allow you to focus in on specific regions on the page. Some will only allow you to get a full page. If you have iframes and frames in your application, some tools can actually zoom in into those frames and provide you with full-page screenshots of the content of that frame, which is very helpful in those cases. If you're running your tests on high-end on computers with high-end monitors like a Mac with a Retina screen, then you'll get screenshots that are twice as big as you would expect them to be. So some tools would break because of that. Some won't be able to provide a proper full-page screenshot. Some will provide a full-page screenshot, but won't be able to compare the screenshot with a baseline or screenshot that was taken on a normal computer. And some will work fine in those cases as well. When it comes to mobile testing, sometimes there are issues with rotation of the image, so some of the tools can correct that and make the image right so it can be compared in a stable way. Some allow you to indicate the viewport sizes to apply when taking screenshots. And others also allow you to do page preparations before taking a screenshot. So this would allow you to hide certain elements or to block out some data. So if you're testing against production data, you won't end up having production data or customer details in your test reports. One important thing about visual testing that it can really help with page stabilization because the tool already has the baseline image, so it knows how the screen is expected to look like. So whenever you take, for some tools, whenever you take a visual validation point, it's not just a one-time thing. The tool actually tries and tries again until it gets to a match or some timeout expires. So it saves you the trouble of synchronizing and putting sleeps or waits or whatever. And this brings us to the third step of reporting differences. And the majority of tools simply provide you with image files on the file system, like we saw with WebDriver CSS. You have a file for the baseline image and the current image and the diff image. And although this seems a bit simplistic, it's actually a very efficient way to work. First of all, it's easy to take those images and send them to people to provide feedback. It works nicely with code reviews when you have the code next to the images that have changed. If you are committing those images together with your code, then you're also documenting the code changes that you just did. And if you're working with branches, it's also nice because you have the baselines for each branch along with the code that caused it. There are other tools that do give you more, and they provide you with some kind of gallery and report that shows you a summary of the test and thumbprints that you can drill down to. This one was taken from Selenium Visual Diff. When it comes to updating the baseline, then all of the image-based, of the file-based tools normally provides you with some kind of command line tool that you can use to manage the baseline, so you don't need to go into the files and change their names or anything manually. And there are other tools like Gemini over here that provide you with a nicer UI that allows you to actually view all the checkpoints, the ones that have failed, the red, and you can see thumbprints of the baseline image and current image and diff, and you have a button that when you click it, it overrides the baseline for you, so it makes your life easy. But all of this is very nice, but in certain situations with visual testing, you have very few changes in your application or very few bugs that fail many of your tests. So just to give an example, if you have, for instance, you've just changed something in the footer of your application. And so every checkpoint that takes a picture of that footer would fail for exactly the same reason. And you can think, just imagine how frustrating it is if you have 1,000 tests and now 500 of them just fail for the exact same reason. And so what you would really like to do is be able to just look at that single instance of change once and decide what to do with it, let's say approve it, and have the tool take care of the rest, right? So this is exactly what automated maintenance is, and I'll show you how it's done. So in this case, we have a build that ran, and it had 28 tests in it. It covered 3 browsers and 3 form factors, and all in all, it found 91 differences. Now, it's easy to look and see that, let's say that we're talking about that footer change that we talked about before, that everywhere we see this change in the footer. Even if it's in different form factors of the application, it's still the same change at the footer. Now, so it's very tempting to just go ahead and approve everything with one click. But I won't do it. What I'll do is that I'll ask the tool to group these changes together and only show me the unique ones. So it's done, and as you can see that with all those differences, I only need to look at 2 now, right? The first one only has this footer difference, and I can just immediately accept them. And the other one, if we zoom into it, you can see that it actually contained a bug, so it's really good that we didn't accept it. So if we would accept it, we would actually deny the tool from the ability to detect it, because now it would become part of the baseline and the tool would actually expect the bug to occur. And there are many situations with visual testing that can actually, decision that you make can be automated and save you a lot of time in doing maintenance, and it allows you to scale up to running thousands of tests without really doing much more work. Okay, and that leads us to the last part, to the final part of the talk, and it's where does all of this fit? How can it plug into your existing processes? 2 minutes. Okay, so the quick answer is that it fits in all the stages. When it comes to unit tests, then it's common for front-end developers to use those quick feedback tools or other tools to do visual unit tests of their components. When it comes to integration testing, then we already saw how easy it is to take your existing Selenium test and with a few lines of code add visual validation to them. And the nice added value that you get out of these by doing it at this level is that you get, it can really improve the collaboration within your team. The reason is that once you start doing this visual validation of entire screens of your application, you don't only pick up bugs, you pick up any type of change. And so when a developer changes the application, adds a new feature or whatever, then immediately everyone in the team can be aware of this change and provide immediate feedback. You don't need to wait until someone shows you the feature to the end of the sprint when there will be a demo, or to see it in production by chance a few months later. Okay, so it really works to improve collaboration and shorten feedback cycles. In the acceptance testing phase, it's very common to use a baseline of the previous version to validate the release candidate to make sure that there are no unexpected changes there. Another way to do it in more dynamic environments is to run the same test on your staging and production environments and use the screenshots from the production environment to validate the staging environment, and you get the same value. Only if your application works with dynamic data in production, then you get a more consistent view of both of the simultaneous states of those two environments. And there are many that are doing visual testing in production, either because they didn't have time to do it before they released, but also More importantly, to make sure that there are no missing resources in production, to make sure that if the application is consuming third-party data, that it didn't get any data that it doesn't recognize and get corrupted because of it, and also to make sure that no third-party component like the browser, operating system, or some SDK that you're using have just upgraded and broke your application. So with this, I conclude my talk. Thank you very much. I hope that it was interesting to you, and be happy to answer any question that you may have. Thanks. Go ahead.
So, should I speak to the mic? Okay. My name is Arseny. I'm from Badoo. You were speaking about thousands of tests, and that's exactly what we have. So my question is about your application. So it's Applitools Eyes. So what stages that you mentioned does your application cover, and how does it integrate? So is it a web service, or how does it work? Because I looked at the pricing, and I don't actually understand how can I use the application inside my company's infrastructure. Yes. And also a little bit of nitpicking. The footer of your website says it's 2015. The footer of the Applitools site says it's 2015. Okay. 2016. Okay, sorry.
Okay, thanks for the comment. I don't want to go into too much detail specifically about Applitools. We can do this offline. But in general, it's good for all the stages, and you can have it as a service, as a private, dedicated cloud, or on-premise. Okay? Okay. Next question, please.
Yep. So, what about web-based tools? Are there any tools for testing applications to do comparison of visual testing?
Yes, so some of the tools, all of the tools basically boil down to getting screenshots and comparing them. So when we talk about all these web-based tools, simply they help you get those screenshots to the point to make it easier for you to integrate it in your web test and just get those screenshots and compare them. So for instance, there are tools, visual test automation tools, I didn't show them here, but they actually only take images. So if you have a way to collect those screenshots and place them in a folder on your file system, then you run the tool and it just compares them according to that folder structure. Specifically for Applitools Eyes, we do have SDKs that work with QTP, encoded UI, or just with images in all the programming language, so you fully cover them.
One more question. Does Applitools, do those tools have the possibility to restrict some areas in the applications which should be checked?
Yes. Yes. So many of the tools allow you to indicate specific regions on the page to validate. And with Applitools Eyes, you can also take the entire thing, and then someone who's not a developer can actually draw it on the application itself and specify the areas to check and the areas to ignore.
Okay, thank you.
You're welcome. Any more questions? Yep.
Sorry, do you have integration? Do you have out-of-the-box ready application for continuous integration servers like CD with control or something like that?
Yeah. So the way that it's done is as you saw with WebDriver CSS, you take your existing tests and you integrate the visual validation in them. So it's the same with Applitools Eyes. You have an SDK that goes in there. So if you have something if your tests are going through continuous integration with Jenkins or TeamCity or anything else, and you have a way to collect those reports and it's working, once you add visual validation, it automatically fits there. And if the tool has finds a difference, a visual difference, you can actually, that gets included in the report that you have, usually with the link that you click and it jumps to the dashboard. And of course, there are also APIs that allow you to download everything, every piece of data and image and difference that you can build your own reports and do whatever you want with it.
I'm Mike. Now I'm working for company Sisense. And we are using your tool, Applitools. Yeah, but there are some issues. First of all, usually combination of operation system, browser, and screen resolution, it's the main combination for baseline.
Right.
And usually we use continuous integration with local environment, and of course when we run the same test on different environments, baseline are different. And
Yeah.
it means that we should compare a set of baselines for all environment, yeah?
So you're just, okay, so basically that's the default behavior, but it's very easy to indicate to the tool to allow it to actually compare different environments, just like I showed in these examples. So we can either talk offline and I'll explain you how to do that, or you can find a lot of that information online or contact support. So that's easy, yeah, yep.
Yeah, there is really easy way to ignore operational systems. Nevertheless, there is one more issue. Have you tried to run the same test using usual environment and, for example, using remote desktop connection?
Yeah.
As I understand, quality of the picture is different, and
Exactly.
that's also the reason of the problem.
Yes.
How it can be solved?
Yeah, so what he's describing is the fact that if you have an operating system in your lab and it is, you have the test running there and then someone opens up a remote terminal to that system, then it really changes the images. So that's correct, and that is because you're using remote terminal. You can use VNC or other systems that actually don't change the configuration of the graphics card. The reason is that when you do remote terminal connection, in order to save the networking and not move all those pixels, all those high definition pixels, actually with remote terminal server, it reduces the quality of the video to a point where actually if your application would look like that, really it would be a bug. And if the tool won't report that, you would be mad at me for allowing your application to go out like that. So it does get to a state where things are really different and the tools would show that, but you should either not use at all terminal server connection or just use VNC or other solutions that don't mess up the graphics. Okay? Okay. Okay, thank you very much.
You can continue asking Adam about this stuff on Speaker Corner. So it's just around the corner with flip chart markers, and I think it's really very useful. So thank you, Adam.